Today we're going to be talking about simplifying simple algebraic fractions. But the first thing we need to discuss is maybe what is an algebraic fraction. So as we can see, here are some examples of algebraic fractions. AB over C, M over N minus 2, x squared over x plus 1 times x plus 3, 4pq minus 5rs over y plus z. So really any combination of variables and coefficients in the numerator and the denominator or the denominator will get you some sort of algebraic fraction. What about simplifying fractions? Well, let's talk about something like 6/8. We see 6 and 8 are both divisible by 2, so if we factor out a 2 from the numerator and the denominator, what we can do is cancel those terms out because something divided by itself will equal 1. And then you're left with the simplified form of 3/4. That's the same kind of thing we're going to be doing with algebraic fractions. So let's take a look. Here I have 28 x to the third y to the second over 20x to the second y to the fifth. First thing I want to do is try and find the greatest common factor between the two terms. So let's see. If I break it up into coefficients and variables, first I'm looking at 28 and 20. And the greatest common factor between 28 and 20 is 4. So I'm going to factor out a 4 from the numerator and the denominator. Now I'm looking at my x variables. I have x to the third and x to the second. The greatest common factor between the two is x squared. So I'm going to factor that out of the numerator and the denominator. Now I have y to the second, y to the fifth. The greatest common factor between both of those is y to the second. And so now I just work on what's left. If I factor out a 4x squared y squared from 28x to the third y to the second, what I have left is 28 divided by 4, 7. If I factor out an x squared from x to the third, I'm left with an x. And if I factor out a y squared from a y squared, I'm left with 1. So that leaves me my numerator of 7x. Now if I factor out a 4 from 20, I'm left with 5. And I factor out an x squared from x squared, I'm left with 1. We don't need to write that down. I factor out a y squared from y to the fifth, and I'm left with y to the third. So my answer, since these two will cancel each other out, my answer becomes, or my simplified form, 7x over 5y to the third. And I can check my answer to make sure that there isn't anything else that could have been factored. And there isn't. Let's take a look at something slightly more complicated. 25mn over 5m squared plus 15mn. In this case, what I want to do is take a look at the greatest common factor for all three terms. So 25mn, 5m squared, 15mn. And what I see is that all three are divisible by 5 and by m. Not n, because these two have n, but this one does not. So my greatest common factor is going to be 5m. So if I factor out a 5m from 25mn, I'm left with 5n. If I factor out a 5m from 5m squared, I'm left with m. And if I factor out a 5m from 15mn, I'm left with 3n. So all these 5m's cancel out, and what I'm left with is 5n over m plus 3n. Those are the terms that are left behind. That is my simplest form. Now again, I can't cancel this n and this n because my 3n is connected with the m, so that's one connected term. All right, let's make it a little more complicated now. So first thing we're going to do is take a look at this. We can see it's going to start to involve algebraic expressions. So it's no biggie. What I need to do is just to remember to group my terms. So let's turn to red here. We're going to start with the numerator. So from 3px and 15py, I see a common term of 3p. So the greatest common factor is 3p, and what I'm left with is x plus 5y. Now in my next term, I see I have a negative 2qx and a negative 10qy. I can factor out a negative 2q, and it looks like I'm left with an x plus 5y. Now let me look at the denominator. I have 21px minus 3py. I can factor out a common term of 3p, and I'm left with 7x minus y. Now I look at this next term, I have a negative 14qx and a positive 2qy. What I want to do is try and get it to match up with 7x minus y. If I factor out a negative 2q, then what will be left is a negative 2q times what is going to be 14x, and that's going to be positive 7x. And then if I factor out a negative 2 from a positive 2qy, I'm left with minus y. So now what you can see is I'm going to take it one step further. If you remember the work that we did from factoring and expanding polynomials, we can see that I have 3p times x plus 5 minus 2q times x plus 5y. Did I say? Okay, x plus 5y. So what that means is I can rewrite the numerator as 3p minus 2q times x plus 5y. Now let's take a look at the denominator. I have 3p times in parentheses 7x minus y, negative 2q times in parentheses 7x minus y. That means I can rewrite this as 3p minus 2q times 7x minus y. Now I can finally go ahead and start simplifying my terms, canceling out something common. I see I have a common term, 3p minus 2q, cancels out with 3p minus 2q, and what I'm left with is my answer, my simplified term of x plus 5y over 7x minus y. I can't cancel anything out because these are combined terms. They have to be exactly the same in order to cancel. Let's take a look at this last example over here. 3x squared minus 10x minus 8 over 16 minus x squared. First thing I want to do is change these into factored form. So I'll do the easy one first. I know my denominator is 16 minus x squared. It's a difference of squares. So that simplifies to 4 minus x times 4 plus x. Now I'm going to take a look at my numerator. 3x squared minus 10x minus 8. So here I'm going to have to use the cross method. I have 3x squared, negative 8, and I'm looking for a negative 10x. So I have 3x times x, and then I have a negative 8, so factors of negative 8, that'll get me a 10. I'm going to use a 4 and a 2, and I want my 4 to be positive and my negative 2, so that when I cross multiply here, 3x times 4, I end up with a positive 12x. Oh, hey, I just realized something. This needs to be negative. So what I need to do is switch these around. I thought that was going to be positive. All right. So we can go ahead and switch this around, make that negative, make this positive. So this is going to be a negative 12x, and this is going to be a positive 2x. So now that gets me my numerator as x minus 4 times 3x plus 2. So now I've simplified to this point. there's a problem with my answer, and it was intentionally meant to be this way. I have x minus 4 and 4 minus x. They're not the same thing. This is positive, this is negative, this is negative, this is positive. Same over here with my 4 plus x. This is negative, this is positive, this is positive, this is positive. All right. So what I have is a problem. These don't match up. I can't cancel anything out. However, here's what I can do. We're going to leave our numerator the same. So x minus 4 times 3x plus 2. What I can do is factor out a negative from my first term. So if I factor out a negative from 4 minus x, I'm changing that 4 and making it negative, and taking this x and making it positive. So what I then have now is x minus 4, because I've factored out a negative for my first term, and then the other one remains the same, 4 plus x. Now what I see is that I can cancel out this x minus 4 and this x minus 4, and what's left is my answer of 3x plus 2 over 4 plus x. I guess you don't really need those parentheses if you're not really multiplying by anything else, so we can just go ahead and leave those where they are. Alright, if you're a little confused on this part of why a negative was pulled out, we'll definitely talk about that more next time.